Okay, guys, so now we're going to look at the second half of 7-2, still dealing with inverse functions. Um, kind of taken up in the middle here. So the first half of this lesson, I showed you how to find inverse functions. Like it gave you an equation and you were asked to find its inverse. Today what we're going to focus on is testing whether or not two functions are inverses of one another. Okay, and there is a theorem test, however you want to refer to it, that will show us whether or not two functions are inverses of one another. And here's what it says. Two functions f and g, so those are the names of our functions. We have function f and function g. So two functions f and g are inverse functions if and only if f of g of x equals x and g of f of x equals x. Okay, so this is the test. So what this means is we don't want to try and figure out the inverse of one of them and then figure out the inverse and see if it works. This is the only test that will work. Okay, and this is the only one that I will accept on a quiz or a test situation. All right. So what we're going to do is we're going to be using this combination of functions or composition of functions to figure this out. So we're first going to plug in the g function into the f function, see if we get x, and then we're going to plug the f function into the g function and we should also get x. Okay, so let me show you how this works. So the directions will say something like determine whether each pair of functions are inverses. Okay, and then you'll be given two functions. So here's the first set. F of x equals 3/4 x minus 6 and g of x equals 4/3 x plus 8. Okay, so we want to use this test to see if it works. Okay, so let's figure out f of g of x first. So that means we're going to take the g function and put it into the f function. Okay, so we're going to take this g function and put it in the f function. So 3/4 times, here's our g function. Okay, so we literally took that g function and put it in the f function. Okay, now if we distribute this in here, the 3/4 times 4/3, they kind of cancel out, so we just get a 1x, plus 3/4 times 8, well, 8 divided by 4 is 2 times 3 is 6. Okay, then we just simplify, so we get x. Okay, so it looks like it works one way, because we got x, and according to our test, that's what we need. Okay, now we need to make sure that it works the other way. Okay, so now let's find g of f of x. So now we're going to take the f function and we're going to put it into the g function. Okay, so 4/3, here's our f function. Okay. Okay, so if we distribute, again, the 4/3 and the 3/4 cancel out to get a 1x. 6 divided by 3 is 2, times 4 is 8. So it looks like we get x in both cases. So if we look back at our test, two functions, f and g, are inverse functions if and only if f of g of x equals x and g of f of x equals x. And sure enough, they both equal x. Okay, so are these inverses? Yes, they are. Okay, let me show you another example. Okay, here's our f function. F of x equals 2x and g of x equals negative 2x. Okay? All right, so let's figure out f of g of x first. So we're going to take our g function and put it in our f function. So 2 times negative 2x, well, looks like we get negative 4x. So far that doesn't work. Now just for purposes of notes, let me show you what happens. Okay, so now let's find f or g of f of x. So we got a negative 4x, so according to this, I mean, we know, it's not going to work, but let me show you this. Okay, so now we're going to take the f function and put it in the g function. Well, we get negative 4x again. Okay, again, just because they're the same thing doesn't mean that they are necessarily inverses, okay? Because our rule or our test says they have to equal x both times. They don't have to equal the same thing both times, they have to equal x both times. So in this case, yeah, they both equal the same thing, but that's not x. So in this case, no, they are not inverses. Okay, so just be careful with that. Now again, this is the test that you need to do. All right, don't look at this one and find the inverse and then see if it matches. Okay, that's not what the test says. So in a quiz or a test situation, that wouldn't fly. All right, this is what you need to do. Okay, I have one last example, short notes today. One last example. So for this particular example, we want to find the inverse, then graph the function, and its inverse. Okay, and here's our function. F of x equals 3x minus 2. Okay, so let's think back to yesterday in our steps. Our first step is to say y equals 3x minus 2. Flip-flop the x and the y. So x equals 3y minus 2. Solve for y. Add that 2 over. Then we're going to divide by 3. Now because we're going to be graphing this, I'm actually going to write it like this. Okay? Just because now I know, okay, y-intercept slope. Okay, so another way you could write this, and here if I put this back in function notation, x over 3, and like this 2/3, like again, because we're thinking of a y-intercept, if you want to think of it as like, 0.6 repeating, that might help you find that y-intercept a little bit easier. Okay, so let's see what this graph looks like. So this was our original function that we're going to graph. This is our inverse function that we're going to graph. Okay, and the main reason I want to show you this is because there's another little property of these that's kind of interesting. Okay, so our original function looks like the y-intercept is negative 2. Slope tells us to go up 3 over 2. 1, 2, 3. I'm sorry, over 1. Over 1. 1, 2, 3. Over 1. So it looks like that's the line, and this is f of x. This is my f function. So I'm just going to put a label there so I remember which one that one is. Now this one looks like my y-intercept is about 0.6, so like maybe right about there, and then I'm going to go up 1 over 3. So up 1, 1, 2, 3, up 1, 2. So this is my inverse. Okay, now what's kind of interesting about these inverse functions is that if you have your original and then you have your inverse, they're actually going to be reflected over the line y equals x. And if you remember, the line y equals x, this was back in, oh gosh, I don't remember what chapter that was, but it cut, I think it was chapter 3, it cuts these quadrants in half this way, diagonally. Okay, so a function and its inverse are always going to be reflected over this line y equals x. Okay, that will happen every time. And if you think about it, it kind of makes sense because what we're doing is we're flip-flopping the x and the y. right? So, you know, if these x's are over here, excuse me, if these x's are over here and they become these y's and vice versa, well, yeah, it kind of makes sense that it's going to flip-flop. Okay? So just another little ditty for the functions and their inverses. Okay? So your assignment for today is going to be on the same pages, so 395 to 396, numbers 30 to 38 all, and then 54 to 64 evens. Pretty short assignment. You should be able to get it done in class. And I will see you guys on Monday. Have a great weekend.